What we are going to discuss today and present to you is some insights from 3 different case studies in Spain, Italy, and Greece that utilize and put into practice 2 different monitoring tools. But before going into detail on the case studies, I would like to briefly put into context what the reasoning behind those is, and is in specific to be able to implement those methods, those monitoring and data collection tools in as close as possible. This is as close as possible to real condition and interaction with actual stakeholders such as paying agency, research institutes, and towards creating evidence-based decisions. That, of course, this is the main goal, but this is also linked to stakeholder needs and assessment tools and other tools such as those presented earlier. So we can say that the case studies help us move from conceptual or participatory parts of the CAP design into a more technical towards more technical aspects and systems and infrastructure that is needed to support implementation in practice. And this is, of course, with respect to compliance, performance, so data knowledge and stock taking. So again, we have multiple data sources. This is a common thing throughout monitoring tools, which we have on-farm data sources and we have off-farm data sources. And on the other side, we have and the final goal is to have to be able to have efficient and interoperable integration with statistics databases such as FAD and FSDN, but also the land parcel identification systems and other external institutes or datasets or data products. So in order to give you the specific examples in this aspect, we will begin with Spain, with the Spanish case study regarding the soil organic carbon map. So in this case study, Itafil from Spain managed to perform and engage a national institute of research in Spain and other evaluators and managing authorities in order to create and implement this methodology on soil organic carbon mapping throughout Spain with a goal to support the CAP soil and carbon monitoring and relevant indicators. Some specific databases on soil samples, satellite data, and other topographic and land cover maps were used as inputs. And on the methods, a machine learning model with specific algorithms on geographic data processing were used in order to follow an open source approach and implement it to produce Spanish-wide soil organic carbon baseline to be used for monitoring purposes. Of course, there were challenges, and such as the uneven soil sample coverage, and those was proven to be region specific or has some specific uncertainties. This was the main outcomes, let's say, of the Spanish case study. And then regarding Italy and Greece, the same monitoring tool was showcased, was demonstrated. Regarding Italy, the main goal was to be able for the Spanish, the Italian research agency with policy users and some regional actors to implement and test the policy monitoring tool for CAP performance assessment and reporting. What this tool integrates is multiple aggregates on specific regions, on specific crop types, on irrigation, pesticides, yields, and all the data come from actual pilot studies of another Horizon-funded program. So by integrating farm-level data from actual farm calendars and sensors, this dashboard provides regional indicators and various indicators and map visualizations to the stakeholders on extrapolated and estimated regional performance data. So it has an area-based algorithm in order to extrapolate regional data into to extrapolate specific pilot data, a sample of the region, into a regional estimate. Of course, this was proven to be potential for harmonized monitoring across a region, or to check regional standing on specific metrics, but also has some limitations as it was proven to be more accurate when there is real administrative data present and not only a sample, not only pilot samples. And regarding the Greek policy monitoring tool, we implemented this tool, but with the goal of exploring and assessing its potential with integration with those external data sources as Ajax and LPIS. The main stakeholder was a Greek paying agency, OPKP, but after its dissolution, this let's say collaboration was discontinued, and other external experts from also the Greek Insurance Institute of the farmers had a participation. The main focus of this case study was to be able to be in North Thessaly, and we focused on crop yield metrics and yield statistics that would implement some scenarios, regional scenarios on stress on specific crop types. There were some findings regarding the adaptability for the tool for this risk assessment and using evidence for risk purposes. But also there were some challenges regarding low engagement from the stakeholders and the lack of official data sets in order to be able to evaluate a more concrete example. Now, a few words about what is common on those three case studies is that the results show that all those the monitoring tools is able to be implemented. It provides data sources. It provides data within specific limitations, and the systematic tracking of those outcomes is feasible. These case studies also complement the integral cases by shifting a focus to operational systems. Of course, the foundation of those is interoperability, actual infrastructure that can combine multiple data sets and workflows. We can say that the three case studies, what they have in common is strong dependence on data integration. But in order to implement those, you need a reliable technical capacity to have specialized expertise in order to be able to run this infrastructure and utilize it. And the main takeaway, we can say that those monitoring tools are promising for evidence-based CAP, but wider uptake depends on stronger infrastructure, interoperability, and institutional commitment on this sense. We will explore those in greater detail with examples for the specific case studies in the upcoming session. But I wanted to give you an overall overview of the thematics and what happened in each one of the three case studies. So thank you.
I actually have a question that is very much in the same vein as what Fernando asked in the chat. So maybe since he asked about Spain, we can start with you, David. If you could present, maybe what did you perceive as the biggest challenges in your case study, and what did you do to address them?
Well, in this case, I think we had the advantage that we already had lots of data collected for the last 10 years, lots of data about soil information. But we had to start from scratch, collecting the soil data to perform our geostatistics. It wouldn't be possible in the time frame of the project, and probably in the time frame of drafting a new proposal of a strategic plan and so on. So I would say it has not been difficult for us to do the map because we had the data, but if we hadn't had it, it would be a real nightmare.
Okay. So in your view, the process was actually quite smooth?
Yeah, nowadays technology is there. There are lots of ways to do geostatistics. Maybe 10 years ago, it was difficult to find people skilled enough to do that kind of advanced statistics. But nowadays, there are lots of free software, as George just has said, lots of scripts to do it in Python, in R, and statistical packets. So it's true that to do something, let's say, academically robust, you need the skills. But to produce some data is quite straightforward nowadays, with the amount of technology that we have and artificial intelligence that helps you a lot to do the scripts to process the data and create the maps.
Yeah, I think your case study was actually a good example for me on how you can be creative with different kinds of tools, combining different tools and data sources to address actual data gaps, right? Because that's, in my understanding, the main point of your case study. So you don't have data for everything, and then you use a combination of actual data and machine learning to.
Yeah, of course. When you talk about soils, you never have enough data because the soils are very variable, very heterogeneous. So no matter how much data you have, it will never be enough. So you have to rely on other variables that are easier to model, like climate or derive variables from elevation models, and especially the land use. The land use tell us a lot about how is the soil, about that. And an important topic of our case as well is what is the alternative of doing this. So we are performing this with machine learning, earth observation, and some samples. The alternative is to go to the field, perform like a large field work, and Spain in the current strategic plan for the evaluation is doing that. They took like 16 soil samples over the country. The budget of that intervention of that project is massive, and the government is pretty clear after seeing this project and some others that probably they cannot keep on this level of soil sampling for a long time. So like new technologies comes to improve the monitoring in the sense that they are not able to allocate enough money to perform this kind of sampling in the long term.
Okay. But maybe, sorry, we'll move to the next case study. But just one thing is the machine learning, on the other hand, you also have then the errors that come with the like extrapolation, right? You still had to perform some sort of validation on the ground, right?
Yes, well, more or less always the procedure to do this kind of models are the same. So you collect data with samples taken from different database, and you save certain amount of that data for validation. Normally 70% to create a model and 30% for validation. That's the normal. Could be 80-20, but more or less like that. With that 30% of points that you have, you realize a cross validation, and you have some metrics about how good is your model with different variables. We've done this in this case of this project, is for cell organic carbon, and it's a variable that could be modeled. I would say that very well. There are other variables, other soil variables like soil texture that could perform well as well, but there are others like content of potassium and phosphorus that are almost impossible to model because they are like very local. And very local. Every farmer may have a different approach regarding fertilization. So it's impossible to create a model that incorporates the behavior of each farmer. So depending on the target, these models can give you a good idea.
Okay, thanks. Great. Maybe we can go back to Yorgos. What was your biggest challenge? What do you think?
Yes. In the Greek case study, maybe the biggest challenge was that data access limitations, as the initial goal of the case study was to be able to combine the existing pilot studies datasets from farm calendars and in situ sensors to combine them with administrative databases. So this was one of the major aims of the case study, but we weren't able to test this goal. So we had to diverge from this main goal and contact and find other stakeholders in order to be able to test similar questions regarding how, for example, those data on, for example, irrigation and yield on wheat or on potato, how those can be utilized in order to provide a regional risk or a regional baseline in which above this level we can say that there is a serious risk for the yields or for the organization to cost for the organization, especially the insurance organization, or below this level there is a moderate risk, or things are going according to the previous year's image or the previous year baselines. So yeah, this is what can I say about the challenge. Maybe we can say also a challenge was to engage the stakeholders, because it was difficult to maintain a continuous collaboration with almost all the stakeholders involved in the case study. So this was also reduce the feedback that we could have, and the knowledge we could have gained. These were all, let's say, the drawbacks or the challenges, if I can summarize them.
Okay, thank you. So if I understood correctly, you did end up working with some real data, but you sort of changed the research question. So
yeah, we had to modify the research question during the process.
Okay, but that was basically to stay relevant. So yeah, my next question will ask about that, but maybe now we can ask Christian, what was your experience? What was your biggest challenge?
Hello, everybody, first of all. Well, basically, since our case studies in Italy was on the policy monitoring tour as well, basically we found out the same challenge that Georgios has already explained, because also in the Italian use cases, we started with the idea with combining some on-field data with some administrative data that hopefully could come from FADN, basically, because we engage as a stakeholder, CREA, that is the National Research Agriculture Center in Italy dealing with FADN. But unfortunately, also in our case, we didn't have the data availability from them. And so also for us, we decided to switch the case studies from using real data. We switch in a sort of demonstrative sections, like 2 sections on how this policy monitoring tool could work in order to train CREA and the stakeholder, basically the Ministry of Agriculture, how this instrument, this tool could be an added value with the future CAP monitoring plan, and especially on the ex post evaluation of the CSP. And well, this is the main challenge. The other challenge was no, basically this one. The stakeholder was very interested in this case studies. I have to say that they tried all the best to make this data available, but they couldn't from some technical problems and also on the characteristics of the data that cannot get into this tool. But they were very, very interested, and we received a lot of feedback from them. And also, we started the case studies as a tool for the ex post evaluation. But the feedback that we received, that in reality, this instrument could be a real good tool also for an ex-ante policies assessment for the new CSP. So this is the feedback that we received. But mainly, but basically, as saw in the comments, the main challenge is the data interoperability. That is a challenge that is focused on our case studies, but in general is a main challenge that affect many tools and many potential new tools, because I believe that a policy of how to make all the data coming from different tools interoperable, the first step to go forward to make to make the possibility to play with a lot of new tools on the new CAP monitoring part. But it's something that we have to think about it from a policy point of view, I may say.
Yeah, thank you. That's actually my next question for all of you. And I have this idea that, I mean, I've said it before today, so please feel free to disagree with me if you do. But I think, researchers have a bit of a tendency to create these tools, and we see the relevance. But then when we talk to policymakers, even if we actually get to talk to policymakers, I think we struggle to show that this tool, even though it may be very good and beautiful and so on, it does what it's supposed to do. We have trouble making it relevant to policy. So did you, maybe Christian, because you were already actually talking about this, did you actually have this issue with your stakeholders when approaching them, trying to demonstrate policy relevance?
Yeah, in some cases, yes, but not particularly in this use case. Okay, this case studies demonstrate the fact that was a lack of data interoperability, clearly, because but also in the past, I was involved, for example, in the pilot project called from the passage from FADN to FSDN. Okay, so the passage for the farm accountancy data network from the farm sustainability data network, and so the problems of get the sustainability, feedback because of indicators. Okay, and we evidence the fact that the new tools like DSS or farm management information system, or also the robotics combined with the agriculture, could help us out, not help us out, but can help the member states to collect a lot of sustainability data that theoretically they are already available and storage somewhere, in some private system,
Yeah.
But was quite complex. We make this data available for the administrative, how to say, like LPIS or IAC systems or these kind of things, or FADN, for example, make them available, and so facilitate the getting of this data. And we envisage also that, for example, talking about big administrative system in collecting data like IACS or LPIS, I said before, there is a lack of interoperability within member states. So it's like to say that it's okay. We have some goals to achieve, but there is not a common technology common to all the member states. So it's difficult to put together data coming from the new tools with the administrative database, but also sometimes it's difficult to exchange some experience for the fact that from a technical point of view, the administrative database has different functionality, functions in a different way from member state to member states. This is what I saw. I don't know if I answered correctly to your question.
Partly, I think. I understand this issue. I was actually also working on the transition from the FADN to the FSDN. And I don't think we were struggling in that process so much with the policy relevance, because it was actually pushed by the Commission, right? And it was very policy relevant for the Commission. I think this is also reflected in the fact that now DG Agri is actually pushing this FADN, FSDN system to run the next CAP discussions. But in your process, like within your case study, you did have some policy relevance, I think, because you managed to get the right stakeholders, but the issue was more with the data, I suppose. What about you, David? You also created a tool. How was your stakeholder engagement? Were you able to show them that this is policy relevant?
Well, they are engaged actually with their field work. I mean, for the current strategic plan, they define the methodology doing the field test. So some of the members that are involved in that, they are looking at us in a way that they are doing this, they are doing the same as us in a different way that looks much more efficient. But at the same time, they are always trying to find the weak points of our methodology just to reinforce their approach. But in the last presentation that we did, that the team involved in the field samples were together, that was like 1 month ago in the national coordinating body, they included the idea of using Earth observation data as a complement to the soil testing. So somehow we are, I don't know if they are going to take our product itself, but they are taking our ideas of going towards a methodology that incorporates these other models or new technologies and not only base everything on the soil sampling. So somehow we are successful in the idea they are changing their minds.
Okay. Yeah, it's a bit of a, it's slow going. This kind of change of mentality doesn't go fast. So we have, I think, 3 more minutes. So let's skip the policy relevance discussion with Yorgos. Well, I have another question. What would you say is the main thing that you can transfer? So the main lesson that you could offer to other member states based on either your case study or all 3 case studies? Yorgos?
Yes. So I think the main lesson is to focus on the tool, not on the aspect of just a data provider. Like a tool, especially such complex monitoring tools, they should be seen as a systemic monitoring solution in a broader context. Like I think this segmentation of also data sources and problems with interoperability or getting data that having difficulties in getting data that you know they are there is maybe a lack of officials or authorities to view the whole necessity, to view it as a necessity, but view it as a system, not as a specific need regarding data on soils or data on irrigations or data on yields that I would like to have now or next year. So it's not only to cater the need for having an indicator for this year, but having a system and preserve it and maintain it in order for this system to be able to function without inconsistencies throughout the time, in order to have the true potential, the true additional value on. So this is my view.
Okay.